Hello friends, my today's topic is critical path analysis, and for critical path analysis we do critical path method. In critical path method of network gives the shortest time in which the whole project can be completed. It is the chain of activities with the longest duration of time. Now I am going to explain how we can find out critical path method. Let's take an example of it. For example, there is a activity and duration. Activity is in the form of events. Same 5, 6 and 6, 7. There are 10 activities in it, and the duration for each activity is given. It is in weeks. Five, 6 is of 3 weeks, and 6, 7 is of 14 weeks. Now, what we have to do, there are few steps for determining the critical path method. Number one is we have to draw the network. First of all, step 1, draw the network. Since our activity is in the form of events, so it will be much easier for drawing that activity, that network. For example, 1, 2. 1, 3. These are two activities. One from single event, two events are generating, 2 and 3. Now next one is 4, 2, 3. Now next one is 2, 5. Next is 3, 4. Next is 4, 5. Next is 3, 6, 4, 6 and 5, 6. And next is 6, 7. This is how we will make a network with the help of this diagram. Now what we have to do is we have to find out the earliest time E and the latest time L of each activity. Now what is E? E is the time at which an activity can begin at its earliest, and L is the latest finished time by which an activity must be completed in order that the project may not be delayed beyond the targeted completion time. So what we do for finding out E, we use forward pass method, and for finding out L we use backward pass method. Now let's see how we are going to find out E and L of each event. Now let's say 1 is our starting event. Here this is mandatory. From the starting we take E as 0. We take it is starting, the activity is starting from the 0 time. Next, from since we have not written the duration over here. First of all, we will write the duration over here. 1 to 2, it will take 15 weeks. Next, it is also 15 week. This is 3 week, 8 week, 12 week, 14, 1, 5, and this is 14. Now we will find out E of each event. Now for the starting event, we will take E as 0. Next event is, if we count, we use Fulkerson rule, then we have to go to second event. Then the second event will be duration plus the E of the previous event. Duration is 15 over here, and E of the previous event is 0. We have 15 plus 0 is equal to 15. Now we will switch over to the next position, that is third. Now we have to find out E of the third event. Now there are two arrows which are going to 3. Now what will be? There will be two values of E. Two values of E means E will equal to, for example, when it is going from 1 to 3, then E will be equal to 15. 15 plus 0 is equal to 15. When we will go to 3 through 2, then E will be 15, this 15 plus this duration plus 3, this is 18. In forward pass method, we take the maximum value of E, that will be our E over here, and this E will be cancelled. Now we will go to the fourth point, that is our fourth event. Here we can see that what we will take, since value of E over here is 18, for E at this 8 plus 18, that is 8 plus 18 is 26. Next is fifth event. For fifth event, we have two, similarly like we have in 3, we have two arrows which are going to fifth event. Now here we can see this is 1 plus 26 or 5 plus 15. Which one is maximum? We will take that value. This is 27 and this is 20. We will cancel out this value and we will take this value as 5E value is 27. Now at point 6, there are 3 arrows going. Now value of E will be either 12, this one, this duration plus, it is coming from 3 actually, then 12 plus 18, or it will be 14 plus 26, or it will be, what it will be? It will be 27 plus, this is 3, 27 plus 3. Out of these 3, 14 plus 26 is the maximum value. So we will take here E is equal to, what will be? That will be 40. Next, E is equal to, for seventh event, we have 40 plus 14, that is 54. This method is known as your forward pass method. Now, since it will be very complex if I will tell how to find out backward pass with the value of L with the help of backward pass method. So I will make this diagram again. You can see over here, it will be much bigger. I think so. This is second activity. This is how they are connected. Fourth, fifth, this is sixth, and this is seventh. These are arrows. Arrows are always from left to right. Now we have find out the value of E. From this we can take the help of this previous you can say method. This is E is equal to 0. Here E is equal to 18. Here E is equal to, this is 15. Okay, now E is equal to 26. This is E is equal to 40. Here E is equal to 27, and the last one is E is equal to 54. Again I will write down the durations over here. This is now this is 5, 8, 3, 15 and 15. Now we have find out the E, that is our earliest start time from this method. Now next we will find out L for each event. Like for 7, since it is the backward pass method, now we will be going from this direction. Here L we take as, for example, we took E as 0 and L we will take as 54. That is the latest, that is the maximum time available. We have to adjust our activities between this time. So now for this, in forward pass method, what we did was we added the duration to the previous activity. But in your backward pass method, what we will be doing, we will be subtracting 54 minus this from the succeeding activity, that is 14 is equal to 40. Next we have to go to fifth point. That's it, same like that. We have to take a proper step in each iteration. Now here L is equal to, what we will do, that is 40 minus this 40 minus this 3. It will be equal to 37. L over here is 37. Now we will go to L. Here 4. Before 5 is 4. So for 4, since two activities here in forward pass method, two activities were converging at a point. But in a backward pass method, two activities are diverging from a point. So here there will be a confusion. So which L we have to take, I will show you over here. Now you can see that we can come to 4 by 7, 6, 4, or we can come to 4 by 7, 6, 5, 4. So what will be L value over here? That will be 40 minus 14. What will be 40 minus 14? Or we have 37 minus 1. 37 minus 1. Here in forward pass method we took the larger value, but in backward pass method we will take the smaller value. We will cancel out this and the value of L will come out to be 26. Now we have to go to third point after fourth. Similar case is over here. Here there are L, there are 2 points which are diverging from it. So we have to take the appropriate L over 3. L is equal to, now you can see over here, this is L is 40 minus 12. Previous event is 6, 40 minus 12. And next is 4. That is your 26 minus 8. This 8. 26 is L over here. 26 minus 8. What will be the value over here? 40 minus 12 is your 28, or this is 18. Which is the smaller value? We will take that. This value is cancelled. We take the smaller value. Now L value is 18 over here. Now we have to go to point 2. That is L is equal to 18 minus 3. That is equal to 15. Now similar condition are over here. Diverging points. So L is equal to 15 minus 15 or 18 minus 15 is equal to 0 is equal to 3. So which value we will take? Yes, obviously we will take the minimum value over here. So E and L. So we have find out the value of E and L over here. E is our earliest start time and F is our latest finish time. Now, how to find out the critical path method from these two times? For this, we have to make a tabular format for it. I will keep it aside. Here you can see I will write down the activity. Activity is 1, 2, 1, 3, 2, 3, 2, 5, 3, 4, 3, 6, 4, 5, 4, 6, 5, 6, 6, 7. Duration. That is 15, 15, 3, 5, 8, 12, 1, 14, 3, 14. Now, start time, finish time. Total float. Start time has 2 times, that is earliest and latest. Finish time will have 2 times, that is earliest and latest. Now, what is the earliest time and latest time? Earliest time is the earliest time at which the activity can start, and it is the latest time at which the activity can start. Here finish time is the in finish time we have earliest time at which the activity can be finished earliestly, and in the latest time we can how late we can finish off the activities, so without delaying the project. Now, before proceeding to it, I want to discuss 2 terms which I will be using in it. That is, this is, you can say, that is our E and this is our L. We have find out E and L value from this diagram. You have seen this is network, this is E and L. We have find out the L, but there are 2 more terms which we will be finding out. That is your latest and earliest. Start time latest and finish time earliest. This is T, E, earliest finish time, TEF, earliest finish time, and TLS, that is your latest start time. Both have formulas, that is E plus TIJ and L minus TIJ. What is What is TEL? TEF, that is earliest time, plus TIJ is our duration, and L minus TIJ. Now we have to find out these 4 times, and then we can find out the total float. What is total float? Total float is the difference between the maximum time available to perform the activity and the activity duration. So this is known as the total float. If the total float is 0 for that particular activity, then that activity is a critical activity. This is how we can find out the critical activity in the network. So let's solve this problem now. Let's solve this problem. Next is E. Okay, now there is a simple rule for it. For example, for 1-2 activity, we take the earliest time of 1. Now I will take this diagram again. It will help us out. So what is value of E at 1? You can see what is the value of E at 1? It is 0. So we will write over here as 0. And next is what is the value of L over 2. For 1 we take the value of E, for 2 we take the value of L. So that will be the total maximum time from 1 to 2 at events. So E is the earliest time and L is the latest time. So total time how we can find out when we will take E of 1 and L of 2. What is the L of 2? You can see over here. What is this? This is 15. Here I will write down 15. For 1, similarly again for 1 it will be 0, and for 3 it will be, you can see over here, what is the value of, where is L? This is 18. Now write down 18. In similar fashion, we will write down the value of E and L for each activity. Like this, I am writing down for 2, 2, 2. You can see it, 15, 18, 18, 26, 26, 27 and 40. Similarly over here, 15, 18, 37, 26, 40, 37, 40, 40, 50. Now what will I do? I will find out these 2 times with the help of these formulas. Now for TLS it is L minus TIJ. This is TIJ. L minus TIJ. This is 15 L minus TIJ. That is 15 minus 15. That is TLS. Latest start time. That is 0. 15 minus 15 0. 18 minus 15 is 3. In similar fashion, I will write down the rest of the TLS. This is TLS 36, 26, 37 and 40. Now with the help of this formula, I will write down the earliest time. Earliest time will be E plus Tij. That is E this plus Tij. That is 15. 0 plus 15 is 15. Similarly, I will write down the other values too. Okay. Yes. Now I have written the whole table. I have found out the earliest time, I have found out the latest start time and earliest finish time and the latest finish time. Now what I have to do, I have to find out the total float. For total float there is a formula. As I have told you, what is total float? Total float is the difference between the maximum time available to perform the activity and the activity duration. So what will be total float? Total float will be, what is the difference between the maximum? That is latest time minus earliest time minus the duration is Tij. Now we will find out the value of total flow. What is L of the first activity? That is 15 minus E is your 0. 15 minus 0 minus Tij. This is Tij. That is 15 minus 0 minus 15. This is 0. Similarly, 18 minus 0 minus 15. That is 3. Similarly, we will find out the whole values of total float. 3, 0, 17, 0, 10, 10, 0, 10, 0. As I have told you earlier, the values which have values which have total float of 0, like you can see over here, the activity 1, 2, activity 2, 3, activity 3, 4, activity 4, 6 and activity 6, 7 has a total float of, you can say, 0. It is a 0 total float. There is no time available. We cannot afford to have a slag over here. We cannot afford if the activity is delayed over here. So what I will do, let's take the previous network. You can see I will taking a different pen for it. You will see over here, is it visible? Now from 1 to 2, I will have 1 to 2, 1 and 2 is our critical activity. From 1 to 2, next is 2 to 3, 2 to 3, next is 3 to 4, 3 to 4, next is 4 to 6, 4 to 6, next is 5 and sorry, I have said wrong one. 6 to 7 is our critical activity. Right. And this is the 6 to 7. Sorry, this has the total float of 10. It is not right. 6 to 7. So our critical path is, is 1 to 2, 2 to 3, 3 to 4, 4 to 6 and 6 to 7. This is the critical path analysis, and the critical time is 54 weeks. This is how we will find out the critical path in this network diagram. So I thought this lecture might be very useful for you. Thank you very much.